Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you'll get everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode to get a $20 credit and launch a new server in under a minute. And are you struggling to keep up with customer requests and letting errors slip into production? Want to try some of the innovative ideas in this podcast but don't have time? Data Kitchen's Data Ops software allows your team to quickly iterate and deploy pipelines of code, models, and datasets while improving quality. Unlike a patchwork of manual operations, Data Kitchen makes your team shine by providing an end-to-end data ops solution with minimal programming that uses the tools you love. Join the data ops movement today and sign up for the newsletter at datakitchen.io/DE. After that, learn more about why you should be doing data ops by listening to the head chef in the Data Kitchen at dataengineeringpodcast.com/datakitchen. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. Your host is Tobias Macy, and today I'm interviewing Kevin Moore about Quilt Data, a platform and tooling for packaging, distributing, and versioning your data. So, Kevin, could you start by introducing yourself?
Hi, thanks, Tobias. So I'm the co-founder and CEO of Quilt Data. My background is in computer architecture and database systems, but a few years ago, I got to thinking about how there were so many amazing tools for managing code, but we didn't have the same things in the data world. And having worked in data processing from thinking about it from the hardware systems up through memory, through internals of database systems, it was really fascinating to think about it from the application standpoint, and I just couldn't help be struck by the lack of the collaborative tools that we had for code in the data sets.
And do you remember how you first got involved in the area of data management?
So I was working, my last regular job was in the research labs at Oracle, and after deciding it was time to move on from there, I was thinking about the transition in computing to the cloud and thinking about what a fascinating transition this was really for the whole world of computing, to be moving essentially almost all of the bulk of the world's computing into a few massive data centers. And the thing that kept hitting me was what was happening to the data. And one of the major challenges for working with large data sets was always bringing data together, getting the pieces, if you will, from the Oracle's days, we were working in tables, getting the table fragments close enough together to join them together. And now, instead of data sets being distributed in servers in server rooms all across the country, now those servers were all in the same room on the same super high-speed network. And it just got to be thinking, well, this is really an exciting time to move into and really an inflection point in terms of data management. So I decided that it was time to think about switching from the internals to thinking more holistically about the whole system.
And as you mentioned, the intent for Quilt is to create some tooling to enable for collaborative use cases for data. So I'm wondering if you could describe a bit about the origin story of Quilt and what the initial use case was for it.
Yeah, I'd be happy to. So going back a ways, I mentioned just a second ago this idea that there were collaborative tools for code but not for data. I was actually sitting in a dinner having a conversation with a woman who, of all things, worked at a charity in Kenya, and her passion is helping women and girls stay in school by managing their health. And she said something, though, that struck me. She said, we don't have any way to hold the government and the schools and the organizations, even the NGOs that she works with, accountable. And said that where she worked, she dealt with corruption all the time, and what was really needed was accountability and evidence. And the piece that she was missing, as grandiose and ironic as this sounds, but was actually a way of pulling the data together, putting that evidence together. And this is where that idea came into play of like, gosh, if this was about software, I would know exactly where she could set up a code repository to share some open code. But how could I tell her, here I am, PhD in computer science, I was working at Oracle, I should know to tell her, where to go to just start working on a database and get set up and running and share that and let people upgrade. And it occurred to me, I was like, well, I could tell her about RDS, I could tell her about BigQuery, but none of those tools fit her need. There wasn't any place that they could just get a simple tool together, put a data set together, have others react to it, contribute to it, collaborate on it, and distribute it in an efficient way. So I guess that's in some ways the origin story, that moment got me and my co-founder thinking like there should be a better way.
For somebody who is using Quilt now that you've been able to build it up and iterate on it a few times, what does a typical workflow look like for being able to step through the life cycle of the data that they're using within the Quilt platform?
Happy to do it, but I just want to give at least a little hint of what's in between. So with this idea in mind of creating easy collaborative tooling around data sets, with a vision of making a place in a system for people to connect all the world's data and do it a lot more easily than what was available at the time, we really had to change our strategy dramatically. So the first vision, the first product we put together to execute on, I guess it's the same vision, but the first product we put together to work on that vision was very, very different. So when I describe what people are doing with Quilt, it'd be important to shift the kind of the mental model. And so instead of, we tried to build something that we thought was more like a GitHub for data, where there was this sort of social hub in the cloud, and the idea was you could just sort of start a project from clean slate, or you could bring your data sets there. And that really didn't work for several reasons that maybe are not as related to this interview, but we switched our mental model because we really needed something that helped people get started right away. And it occurred to us that after watching people use this social database in the cloud that we had built, the most common thing that people were doing with it was export to CSV, download CSV, read pandas, and pull it into their Jupyter notebook. And so having read Lean Startup and all those sorts of things, and having gone through Y Combinator and telling us to listen to our users, listen to our customers, and iterate, we scratched our heads and said, I think we're doing this wrong. So we scrapped that first product completely, and instead we were inspired by, the first inspiration was honestly really package managers, but it morphed into Docker. And we had been using Docker to deploy our software, and we realized that installing, a running software, a runnable software environment was so easy. And the same way, installing and importing a library, if you're running Python with pip, if you're running JavaScript with npm, was so much of an easier process than this searching Google for the data set that we needed, finding out what the formats were, finding out where the files were, what are the URLs, downloading them somewhere, finding a staging area, figuring out how to unpack them and interpret them. We started thinking, can we get that kind of experience, that pip install for data? So as a very long and winding way of explaining what the workflow is with Quilt, the simple answer is it's entirely varied depending on what each person and organization's data sets are and what their tools are. But a very simple get starter workflow is I'm collecting some files, say CSVs, maybe there's some images, and I want to pull those into a Jupyter notebook. And now I want to share that Jupyter notebook with my collaborators, and instead of having to throw everything into the same Git repository or, worse, like, park it all in some S3 bucket or something, we found a way of separating the data versioning and the data transport from the code transport. So you can check your notebooks right into GitHub as you always would, and now you can wrap your data assets in this Quilt and quickly and seamlessly in a single line of code import that into your notebook, and the notebook will be portable. The data set is identified by its name, and inside Python it acts like you would want, which is to say a Python object.
Backtracking a bit more to what you were saying about the social platform for data, is that something that when you abandoned it, you ended up leaving some remnant of the code for people to explore? And also, I'm curious how that original vision compares to some of the work that they're doing at data.world, or if you're familiar with that platform.
I am. I think it's very similar to data.world. Our model, I think how it works under the hood and the way of interacting with the data sets was different, but the spirit of it is very similar. And I have followed them a little bit and wish them the best of luck in doing what they're doing. We also saw that a really successful effort around a really successful example in that space is actually what Kaggle is doing. Kaggle's put together a tremendous collection of data sets and kernels, and it's a fantastic source of open data.
And now, with the current model that you have of this package of data, I'm wondering if we can just start by stepping through what the actual data package consists of and what the various layers of it are for somebody who's first getting started with working with it.
Sure, happy to. So a data package is a collection of serialized data and metadata. Essentially, it's a way, a metadata wrapper around a transportable data set that will take it all the way. The libraries that come with Quilt are able to take that data set all the way into memory, into code. So inside Python, you can see a data set as a Python module, if you will, or a collection of ready to use, ready to analyze objects. The kind of canonical example of that is the pandas data frame. But it's certainly not limited to tabular data, so it's not the case that you'd have everything there. But that's simply one example of an object that is kind of ready to go in Python and in the form that, say, a data scientist would want to work with it.
And when I was reading through the documentation, it looks like if you are able to identify or easily see that the data that somebody is first importing into the package is in that tabular format, then when you actually store it in the package, you automatically will serialize it to Parquet files or HDF5, depending on the way that it's formatted. Is that accurate?
Mostly. We don't think of it as automatic as much as that's the default. The package creator can choose the serialization format, and eventually we'll be able to supply plugins for serialization and deserialization. So the idea is that you can, as a package creator, create both the in-memory, in code experience for that data set and standardize that, and also help guide the serialized transportable representation. That said, we want to provide high performance, generally good choice defaults, because a lot of our users, of course, will be using the default. So for tabular data, Parquet is a great choice. It is much smaller in that compression works very well on it by rotating the columnar form. It's easily shardable and distributable, and it's immediately readable in the whole Hadoop and Spark ecosystems, and of course also now Python with the Arrow project.
Do you have any integration points for some of those other ecosystems where somebody can easily import a Quilt package into a running Spark system or Hadoop file system and then automatically be able to easily unpack the data from that package and then just start processing it as they would as if it were just a flat file?
Spark, yes, and at the moment only PySpark, but we're working on that. So we've started with Python and PySpark. We have Excel and R waiting in the wings, and Scala probably eventually, but we're going to see how far PySpark takes us. It'll be interesting to see in the Spark community when someone really clamors for the Scala or native Java implementation or interface.
So you mentioned that one of the initial and main use cases for people using Quilt is within the context of a Jupyter notebook. So when they version the notebook in GitHub and the data in Quilt, what's the process for being able to then recombine those two pieces on somebody else's computer who is using the notebook for being able to try and reproduce the previous person's work?
It's very easy. So there are two pieces. If they want to download a local copy of the data set, they would do a Quilt install, sort of analogous to a pip install. We have a mechanism that's akin to the requirements.txt. There's actually a Quilt. It's a YAML file instead of a TXT file. I'll let that debate happen in GitHub issues. But so this file, you can Quilt install from this quilt.yaml file, just like you would pip install from a requirements.txt. And that would work with something like a popular way of sharing notebooks in a reproducible environment is to use the Binder project, if you're familiar with that. So we've actually written a little plugin for Binder, and you can add a quilt.yaml to your Binder, the folder that you're using for Binder, and that will just work. And when the Docker image is created, it can pre-install all of those Quilt packages, or of course you could just have it set to grab that data on demand from the cloud.
And for the data package itself, can you go a bit deeper into how it's structured and what the interface looks like for somebody who is building or consuming one of those packages?
Sure. The actual nuts and bolts or the bytes, if you will, of the Quilt package, there's a package manifest, which is a JSON, and that specifies the tree, a tree of Python objects, if you will. We're thinking about it in Python, but that tree is actually structured as a Merkle tree, so it's a hierarchical hash tree, and each of the leaves actually can be a list of hashes of individual data fragments. And those data fragments are identifiable by their SHA-256 hash, and you can fetch from the Quilt system by that hash. So it's possible to send, if you will, only the manifest and then load the fragments on demand. We call it a metadata install. And each of the fragments are deduplicated and stored only once at any given location. So the local storage on, say, your laptop or your compute server is essentially a local cache of the data that's backed by Quilt and a Quilt registry. And the Quilt registry, which, by the way, it's not like the one Quilt registry. It's open source. You can run your own. There are multiple Quilt registries running around in the wild, and the intention is for there to be lots of them. And each Quilt registry will only store one copy of a unique data fragment. So this could be, a file or a piece of a file, and using that to allow hierarchical caching and efficient replication of the data.
And within the manifest, is it possible to add some additional metadata about what the data sets are and their intended purposes, or perhaps where they came from, so that you can record provenance of the packages?
Oh, great question. Absolutely. So there's a few ways to add metadata to the package. So each node can have a user-defined or package builder-defined blob of metadata, just a little JSON fragment, or you can supply it in Python as a simple dictionary, and that'll allow programmatic filtering of a package. So, for example, one of our largest data publishers in Quilt right now is the Allen Institute for Cell Science, and they published this amazing collection of cellular images, some of the best cellular microscopy images in the world, and these are very, very large collections of data, or at least by most people's standards, large. I guess large is a relative term in the data world, but several terabyte per package and tens of thousands of images. And a researcher who wants to work with that, say, to feed it into a machine learning model, they could go through that large data package, run a filter on it, and choose out only the nodes that match certain criteria in the metadata, a particular tissue type, a particular cellular condition type, looking for images that have a certain feature in it, and pick out a reduced set of nodes. And that will act also like a Quilt package. They could then, make a local copy of just the fragments that they want, or they could navigate that and feed it into downstream code, like feed it into their model for training. They could make a derived package out of it. They could add to it and publish it as a new data package, a new data set with the results of their predictions. For example, if they were predicting from the images, one of the use cases in the Allen Institute case is predicting from the images with machine learning, predicting where each of the cellular features are. And apparently they've gotten quite good at that. Then the next piece of metadata is simply the human-targeted metadata, which we support a README in Markdown format. So if you attach a README file to the data package, that will automatically be displayed in the data catalog that goes along with Quilt.
And in terms of these packages, particularly in the case that you were describing with the Allen Institute, where somebody might be creating a package that's a derivative of an original one, is it possible to specify a dependency chain or a reference chain where somebody is able to then publish the results of their research and then have it refer back to the source data that was actually pulled into it based on the versions that they used at the time, so that there's one canonical source of the data rather than having to copy it around in a bunch of different places?
Oh, absolutely, and we encourage that. The typical place that you see that is right in the README, but it can also go in the package metadata, which would allow it to be more efficiently searched, perhaps. But the reason we don't have anything more formal is we don't yet know all the ways that people want to express lineage. There's so many complicated dependencies. Typically, these data packages, or at least commonly, let's say a data package will consist of data from many different sources, and sources that are external to Quilt. So there's typically or often links, even if it's just a web page or the page of a lab that produced it, or a government report, the census results, even information about, for things that are private packages, For example, if some of these data sets came from queries of a transactional database, they might have the information about the actual query that's in there so that the lineage can be traced and the source can be traced. It's also possible and not uncommon to see references to Git hashes, which will specify a version of code, perhaps ETL code, that produced some of the derived data.
Yeah, that's really cool. It was definitely an interesting project at face value when I first came across the work you've been doing, but the more we talk about it and the more use cases you describe, it definitely starts to sound even more compelling. And the registry piece in particular is interesting, particularly since it is there isn't just one canonical location. It's something that many people can run depending on their particular needs and be able to possibly pull data from multiple registries to build various packages. So can you describe a bit more about how the registry itself is implemented and the architecture that you've built for it?
Yeah, happy to. So we've designed the registry to be as simple and lightweight as possible. It is really a metadata-only service, and its function is to provide versioning and permissions to the large data collection, and then let the raw storage engine, usually in the cloud, that's something like S3, do all of or as much of the heavy lifting as possible. So the registry service, there's a catalog, which is JavaScript React. In our open source community editions, usually hosted on Nginx. We have a Docker container for that, though in production I think there's a CDN involved. And the registry itself is a Flask service that runs the registry API. It sits on top of a Postgres database, and all of that again is deployed with Docker. So for anyone out there that wants to run your own registry, we have Docker images ready to go, and you can get at least a testable development Quilt registry up and running in about 5 minutes with Docker Compose. And then, as I said before, the goal is to use the storage system for the actual transfer of the data. So the client, which is right now we just have the one implementation that we support in Python, but others are coming down the road. And the client will talk to the registry and get back a package manifest, or even a subset of a whole package manifest. We call it a sub-package. And in it, it'll contain a list of permissioned URLs, and then from those URLs, it can directly talk to the storage system. So if you're running this in the cloud, or you're talking to our cloud-hosted registry on AWS, the client would be talking directly to S3.
And so I imagine that helps a lot, both in terms of managing your hosting costs, but also for people who want to have some sort of optimization in terms of the way that the data is stored, either in terms of cost based on the volume of the data, or optimizing for latency of updates and retrievals for where their main users are going to be. And I'm wondering what other optimizations you've made in terms of the way that either the registry or the client are implemented to accelerate the speed or effectiveness of synchronization from the source repository and the client that's interacting with it.
Oh, great question. So, as I mentioned at the very beginning, I'm a computer architect by training. So the two things I think about most often are latency and bandwidth. So the first thing that we thought about with Quilt and the architecture itself is bandwidth. And the solution for high bandwidth was really to get out of the way. And, these cloud providers are providing really incredible scale in their storage and also incredible bandwidth in and out of them. So the first step is to just make sure that, to the degree that we can, not screw up anything in the way that we're laying out the data on the storage resources, and then not have the registry be a bottleneck anywhere that would reduce the maximum bandwidth available. Now, if you want higher performance than that, oftentimes it's a question, as you said, of latency. And that's why allowing content addressable, being able to address the data fragments by their content, makes caching much easier, because there's not much of a coherence problem if everything's addressed by its contents. You sort of either it's present or it's not present, and you would just need a chain of where to look for it if you don't find it. So it's very easy to set up caching and for Quilt packages, and we've seen that's in use at the Allen Institute. It's in use in a couple of university settings where they still have big network drives that are actually much closer to the compute resources that they're using than S3. So it's easier to kind of install, if you will, a lot of the commonly used Quilt packages into this cache, and then that saves them, of course, upstream bandwidth, but it also cuts down the latency tremendously.
Going back a bit more to the workflow for somebody who is using these Quilt packages, when you get into a team setting where you have data engineers and data scientists, what do you see as being the typical interaction as far as how the data engineers might create and curate these packages and how the data scientists might use and version the data?
All right. Really, really glad you asked the question. So when we've gone into larger data shops, companies that have really forward-looking and really sophisticated data engineering and data science teams and have built, really scalable infrastructure in the cloud, we hear a lot of common problems out there. And one of the first ones we hear is, man, we just have all these Hive tables and we don't really know what they all are, or who maintains them, or which ones we need to keep. So let me just sort of imagine Quilt in a scenario like that, or at least tell you about some of the nascent projects that we have ongoing in a couple of those places, where to oversimplify and generalize what we've heard at several companies now, data are streaming in all the time, and maybe it's coming in through Kafka, maybe there's just Airflow pipelines that are putting together. Usually, often a common pattern is the ETL or the streaming engines are putting together table partitions in Parquet and adding those to tables in Hive. So every night or every day or every hour, every minute, whatever the granularity, there's new partitions being created, tables are updated, and this data set is just constantly growing. What we imagine with Quilt could do there is that Quilt's kind of a final step in that ETL. Data are still streaming in as they were. All the ETL processes that happen are still happening, but those fragments are being registered with Quilt in a way that does a couple of things. First of all, it's going to add reproducibility and versioning on top of that. So instead of Hive, which is really designed for everybody seeing the latest and greatest, whatever the state of the world is right now, we can have essentially snapshots of tables that will say, okay, these were the state of these tables when we did this query, when we trained this model that we're now deploying. So if we have some event that happens in production, we could go all the way from existing model weights and trace that all the way back to training data and the snapshots that fed it. It also can handle permissioning. So particularly in companies that deal with more sensitive data, a common ask that we hear is that different groups, different data science teams should be allowed to see different subsets of the data. And this is particularly interesting, I think, to me in the biotech and pharma industries, where they have research studies and very fine-grained requirements about who can see which pieces of data. And even more interesting, perhaps, is data can be pulled back, and they need to have an auditable trail of, say, who has had access to this, how can we be sure that this data is no longer being used because someone has opted out of this research study, or this patient has withdrawn their permission to be part of this cohort, for example. So anyway, going back to the big picture, I think imagining just a general scenario, though every company, every organization would be different. Let's say you have Airflow building, and the last step of that Airflow pipeline is building a new Quilt package every time it's run. And you might have packages that these packages are kind of the logical view or a set of data on which decisions are driven. So maybe you're used to making decisions in the data science team with the last 30 days of a time series. That could be snapshotted in a package. One of the things that's also exciting about Quilt is that it's very easy to combine tabular data and non-tabular data like images. So there could be something like, for insurance, you might have all of the claim scene photos and all of the tabular data that goes with the history of the parties involved, or the aggregated statistics of the area or the industry. And again, each of that can be updated as usual in the ETL pipeline. So the data engineers are the keepers of the recipes, if you will, these build specifications, and deciding, they hold the keys to which data scientists have access to which data sets, which views of the data, which are these data packages. And also, they're now with Quilt given an audit trail of which data scientists have pulled not only which packages, but exactly which versions of which packages.
Yeah, that's definitely a very compelling use case. And it sounds like with being able to create that audit trail, is that some custom tooling that they might build to automatically register additional metadata anytime a client interacts with the registry? Or is that something that's already by default part of the current Quilt tooling?
The audit workflow is part of a product we have that's our more enterprise tier product called Quilt Teams, and that just gives an admin view. I'm going out on a limb. I believe it's actually available in the open source project as well if you run your own Quilt registry. I haven't gotten any emails that any of our open source partners are using it yet, though if anyone out there wants to, I'd be happy to respond to that email. But no, that's been a feature that's been asked for more in the corporate enterprise setting, where some of our early enterprise partners have really wanted a couple of key features. And the most important was administrative ability to revoke access. And then the second one is that audit trail of saying, okay, where did a particular data package go? Who saw it? And it can even be more sophisticated. It can even go down to if one particular file or one particular even, fragment of a table contains an offending or redacted datum, that fragment can be traced to all of the packages that contained it and all of the versions of all the packages that contained it and all of the users who installed it.
And that's a good entree into discussing the business model for the company that you've built up around this project and the goals that you're trying to achieve through the course of that business.
Oh, sure. So as in all things startup, we're iterating constantly. But what we imagine the big business, it appears to be, we're certainly on a trajectory right now to be an enterprise company. And we're working with some very large enterprises who have very complicated data management and data governance problems. And so our eventual business model is to have an on-prem, fully supported enterprise business model. What we're concentrating on right now, however, is community and developer adoption. So we really want to get the Quilt data package as a standard. The first thing we want to do is we really want to get the community of data engineers and data scientists believing what we believe, which is that data sets should be versioned, and that we should think about data as we're using data and deploying data right now without even necessarily thinking about it in the way that we think about versioning and deploying code. So the first goal is to be one of the many voices who's hopefully changing the industry and the communities for the better and saying, okay, we need this extra capability. We need to be managing our data with the same level of care that we manage our code, with the same level of reproducibility and auditability. And then the second piece is we'd like to have Quilt be an integral part of the stack that people are using to do that versioning and deployment. So to go back to the Docker simply as an analogy, Docker is an essential part of so many companies' software development workflow. Think about all of the projects that are built and deployed in Docker, and with the rise of Kubernetes, I think that's even getting more and more popular. We're doing more things inside Docker containers. We'd love Quilt to be an open standard for data snapshotting and data versioning, and really for data deployment. As you could deploy your software in Docker environments, we feel that Quilt is really a great way to deploy the data asset to get that data into the code that needs to operate on it.
One of the other questions that I have about the project as a whole and the business and how it relates to it are some of the biggest challenges that you either have faced or are facing, and some of the limitations or edge cases that you've come up against that you're currently working through.
Oh man, where do I start? Yeah, I could talk the full hour just on challenges. It's very exciting, and it's full of lots of interesting, exciting challenges. So please don't think that the things I mention here are in any way the limit of the challenges that we have. But let me see if I can zero in on a couple. The biggest challenge for adoption is getting started. And really, I think this may be true for any data project, or any data tool, getting data in. So either writing the connectors or writing the documentation, writing the tutorials, teaching users how to use it, and just making it incredibly easy to get data in. And this is part of what you see in our strategy for having automated build from simple data sources like CSV files and images. But we need to go further. We need to have automatic connections to, say, important pieces of data infrastructure like the Hive Metastore in particular. That's probably maybe the single most burning needed connector. But we also need to work with relational databases and find a better way of snapshotting and database tables from relational databases like Postgres and MySQL without losing our deduplication. That's a huge challenge. Getting data in is definitely a big one. The other one, we're still iterating on what exactly the right abstractions are in terms of data packaging. It's really working for certain use cases where package builders find small is the wrong word. It doesn't have to be small in terms of number of bytes, but logical subsets of objects that can be, installed as a package. But there are other use cases where users like the general approach of Quilt. They like how easy it is to get data into code, but they kind of just want all their data to be accessible as the mental equivalent of one giant package. And so from an architecture standpoint, the implementation and the design of the system would need to be a little bit different there. We had approached this with the thought that users would want to have millions of smaller packages, and we've gotten from at least a couple of early users pressure to say, well, I'd just rather have everything as, like everything under one, package namespace, and I want to do the same kind of filtering on everything. Can you filter across all my packages, or can I just, put everything in one giant package and filter from there? And I'm sure we could, I'm sure it's possible to build that system. It's hard to know how to be the best of both worlds in that case, or which one is going to ultimately be more useful and catch on faster.
And do you have any specific plans for the near to medium term in terms of either new features or new capabilities that you're planning on adding to Quilt, or new services that you'd like to build around it?
Yeah, let me mention a few of those. So the roadmap is really exciting, and would love to talk to people from this audience about contributing to the project. It's open source, and we're glad to take contributors in all of these areas and more. We are working on a few things. So one of the things I mentioned before was an interaction with the Hive Metastore. We're looking at, first and foremost, a first baby step in that endeavor is to have a better concept of a table inside a Quilt package. Right now we have, we started with data frames, which, if you will, would sort of be the logical equivalent of a partition of a table. This is something that almost by definition, or perhaps actually by definition, fits inside your memory in a pandas data frame. But of course, the tables that we work with in practice are much, much larger than this. So what we've done as an MVP, if you will, of tables is that you can group together like schema'd data frames backed by Parquet fragments, and you can use a tool like PySpark to generate a view of a much larger than memory distributed table. So that works today in PySpark. You can take inside a data package, you can have a large table that's distributed into a set of many nodes. Those individual nodes are then materializable as pandas data frames, but in Spark, for example, in PySpark, you can go up the tree one level, and by materializing the parent, you would have a Spark data frame that represents the distributed set of all the children. What we really need to do is prevent a proper table abstraction that maintains the higher level metadata, and perhaps even add some things that, for example, a system like PrestoDB uses that are not natively in the Parquet format. So we've been looking at a project out of Netflix called Iceberg, and speaking to the primary authors of Iceberg, and perhaps we can use that as a table snapshot format inside Quilt packages. And so that's a really exciting potential development. We're also working on a plugin where we could very easily take a snapshot of a Hive table and then create one of these table snapshots as part of a package. So you could build a package out of queries from Spark SQL, or you could build a package from just actually specifying Hive tables and including those as nodes in the package. So that's one. Another one that's on the bigger data side. On the smaller data side, working on a plugin for Excel that actually lets you load data from Quilt packages directly into an Excel sheet. We're working on a more scalable format for the package representation. This is on that, what if people want to put millions, or better yet, tens or hundreds of millions of objects into the same Quilt package? Then, one giant JSON file isn't really the answer. So we're kicking around some more scalable representations of the tree structure. And we're also doing simple management things, like we'd really like to make it easier for the community to run their own registry. So we want to port the registry deployment from plain Docker and Docker Compose to Kubernetes. It'd be great to make a Helm chart for Quilt so that you could really get a production version of Quilt up and running in your infrastructure in a short amount of time.
And are there any other topics or areas of discussion that we didn't cover yet that you think we should touch on before we start to close out the show?
No, I think you asked some great questions, and I think we covered a lot.
Yeah, there are definitely a lot of sub areas that we could cover in much greater detail and spend another 2 or 3 podcast lengths worth of time to cover them. But for anybody who wants to get deeper into those weeds, I'll have you add your preferred contact information to the show notes. And as a final parting question, from your perspective, what do you see as being the biggest gap in the tooling or technology that's available for data management today?
Well, I think, having visited a lot of really amazing data engineering teams, I'm really glad that some of the companies here, particularly here in San Francisco, but even across the country, have been so open with us and taking us in. It's absolutely amazing what they've done. So working with data at scale, I don't want to call it a completely solved problem, but they seem to have a handle on it. The tools are in place, the workflows are in place to work with data at tremendous scale. Harnessing enough of compute power. The algorithms they're using for machine learning seem to be, I'm sure that work is not done. I'm sure it's going to change very quickly, but it doesn't seem to be the problem. They're not limited by that. The limitations seem to be more of in the area of organization and collaboration, and particularly focused on the metadata. So I think I mentioned earlier on, what are all these Hive tables, and which ones do we need and which ones do we not, and did we get the right version, or did we run the query against the right tables, and things like that. So that kind of organizational understanding and being able to share the knowledge of a group in an effective way, I think are the biggest challenges. So in particular, this is fine-grained permissions, it's fine-grained versioning, being able to construct that lineage graph, the raw source of this information that's behind this visualization was here. It went through the following transformation steps. It was augmented in this way by adding these features. That was done with this particular code. Understanding all of that so that companies have a way of debugging problems that arise, but also a toolkit for starting the next project 4 or 5 steps ahead.
All right. Well, thank you very much for taking the time out of your day to join me and discuss the work that you're doing with Quilt. It's definitely a very interesting project, and one that I'm likely to find some use cases for in the near term. So I appreciate that, and I hope you enjoy the rest of your day.
Likewise. Thanks for having me.